let's see how we can approach this problem. Now, what we can see here, what you are given is the transfer function of the system, which is the system behavior in the frequency domain. So what does actually the transfer function is about? It's about the output, which is in this case C of S, divided by the input, which is in this case R of S. So what does relate both the output and input together in the Laplace or frequency domain. So if I want to find the output in the frequency domain, I can directly multiply the transfer function of my system with the given input. And in this case, the input is a unit step function, which means that it's just 1 over S. So that means that my output can be found directly by multiplying the transfer function with the input, which is just an S, times the transfer itself, S plus 2, times S plus 3. Now, how can I transform my output from the frequency domain into the time domain? Now, what we can do here is we can apply the partial fraction. So this would become A divided by S plus B divided by S plus 2 plus C divided by S plus 3. Now, using inspection and the given formulas, we can determine that C of t actually is equal to A, the constant here, at plus B e to the power minus 2 of t from this given formula, plus C. In this case, actually, it's not C s plus 4 plus 3, it's actually S plus 4. So let me correct that. So plus C e to the power of minus 4 of t. Now, this is done by inspection. And before we proceed with getting like the constants or solving for the constants A and B and C, let's just try to understand what does these terms mean. Now we can see that both of these terms actually came from the transfer function itself, this one, and A came from the input, which is in this case a unit step function. So if we go and we just plot these basically graphs. Now let's start by plotting e to the power of minus 2 of x and minus 4 of x and analyze the behavior. Now we can see that both are actually exponential functions that are decaying with time and approaching to actually 0. And if we further analyze the system, we can see e to the power 4 of x actually can approach 0. Here, it can approach 0 faster than e to the power of 2x. Now, what does that mean? Or what does this indicate? These both terms are actually my natural response of the system. So basically, both are decaying to 0. I want you to think about the natural response as something natural in the system, which basically, let's say, like comes from the resistance, the capacitance, or any kind of internal things in the system itself. So the system will start to exhibit some energy from these basically internal components that will ultimately fade to 0. Now, once I apply a forced input, so in this case, we apply, for example, here, let's say A is 2.2, which is the constant. So if I apply something here, now we can see that this is what actually gonna control the system behavior ultimately. So here, the natural response of the system is what actually gonna decay to 0, and my forced input is what gonna leave the or what gonna create the system behavior. So if we proceed here with the question, and if we find using like partial fraction, the cover-up method, we can solve for A and B and C. And we can actually determine that A is equal to 3 over 8, B minus 1 over 4, and C minus 1 over 8. And if we go ahead and plot the final C of t, so we can see actually this is the system that we get. Basically, we can see that the system is the combination of all of these factors with the forced input. Now, let's better understand that. Let's first visualize the input response. Now we can see that the input response is what actually decays to zero. And once I apply the forced input, I can see now I have some change, and this is because it's a step basically input. Then I have a specific kind of constant that the system will approach 2. So in this case, we determine that this part is what does actually contribute to my natural response of the system. And this part is actually what determines my forced response. We can also analyze that when we have e to the power minus 4 of t, basically the system decays faster comparing to basically e to the power of minus 2 of t. And this also related to the poles of the system. So if we want to just quickly find the poles of the system, we know that they are here. We equate the denominator with 0. So we get S2 equal to minus 2 and S is equal to minus 4. So we can see that this actually component decays faster comparing to minus 2, and the effect of this component kind of lasts longer.